Hello. In this video, we shortly will introduce the main principles of distributed systems. So basically, what is it? So if we will go into this definition, so basically it's related to the collection of independent computers connected through the communication networks that works together to accomplish some goals. So basically, we need some kind of a node. So usually it's just a computer or some more powerful dedicated computers connected to the network. And the main principle is because there are different architectures, like there is no shared operating system, no shared memory, and no shared clock. So we won't go deep into the details, but all those three aspects affect some kind of implications, like if we don't have clock, how to align different queries to understand what was the sequence. So there are different issues and different technologies which could be incorporated in the distributed systems. But in this video, we should briefly overview what is the distributed systems, what's the application, and where we can use it. So first of all, why do we need distributed systems? So there are multiple reasons. Probably the main ones should be those. So sometimes we want just to scale the system. So instead of buying every time more powerful computer, we could buy another computer. So instead of replacing, we just adding something extra. So yeah, from time to time, we can upscale the existing hardware, but there is some kind of a moment where we cannot upscale anymore the same device. We need just additional one or new one. So instead of buying a new one more powerful, because there is some kind of a limits as well, we can just buy, for example, not the supercomputer, but some average computers and have multiple of those, and just to use all those resources as one computing, just assume machine, but basically it will be multiple nodes connected and executing the same task, the dedicated task. Also, it gives additional possibility of collaboration. So basically, sometimes via the collaboration, we can divide the data, for example, into different nodes, or the computation can be distributed in different nodes. So the collaboration between nodes also is sometimes in some situations kind of suitable. Supporting mobility, this question is more oriented, like item more oriented. Sometimes the location of the node affects, for example, the latency. If we are closer to the node, we can get the query faster in comparison if we will be sending it from remote node. So yeah, it's partly related to the scaling, but even the chance we could distribute the nodes in different locations also gives some additional values to the end user, to the infrastructure, something like this. Usually when we are talking about distributed systems, at least in our case, everyone understands like the biggest advantage is the availability and fault tolerance. And from one point of view, yeah, like if we have multiple servers, so automatically we will be able to go to one of those if another is failing. If we have multiple copies of the same data, so if one failed, we will be using another one. But basically, in all those items which are listed here, we should be diving deeper and getting a lot of different solutions which should be used to implement it. So it's just not like if I'm using distributed systems, it doesn't seem it's already applying all of those features. It depends on the content, on what kind of distributed systems we are using, and so on. So another element, which sometimes is relevant, is the implemented incremental cost. So it's related to the scaling, which I mentioned before. Like if I want to test the model, first of all, probably I can buy one hardware. If I'm scaling the model, I don't need to buy change the infrastructure completely. I just can buy another element. So I'm not wasting all my resources in advance to buy a supercomputer if I'm not sure will I need it. Maybe I can start from the smaller one. So it's very closely related to the cloud computing, because in most of the cases in cloud computing also we could use some elements of distributed systems. And also we can use the delegated infrastructure and operations. So basically what is more or less cloud computing, like when we are buying the infrastructure, even not buying the hardware by ourselves. So there might be more even elements which defines the advantage of it. And also, like, do we really want distributed systems? Is it really necessary for our project, something like this? So first of all, what we should be taking into account, for example, if I have n simple nodes, like n computers, for example, 5 of them, And if I'm having basically 5 tasks, so if it will be running in one computer and if it will be running in 5 computers, does it mean like the price will be the same, like for 5 or simple ones and one more powerful? Basically, also it depends. Sometimes it could be less. Sometimes if you're talking about more computational resources, sometimes buying one really powerful could have not linear relationship of cost, but even exponential. So every time you should be calculating what are the advantages and what are the disadvantages. So cost could be one of those factors. And also another thing is like we should be modeling, do we really have the data and how we will be able to store the data? Probably, you know, like if I'm running some kind of a software, the software automatically goes into the random access memory, the main memory. And if we have all those variables, so those variables basically is stored in this memory. If we have just a file, it's not opened, so we didn't load it to the main memory, so it's stored just in hard drive, some kind of a long storage. So automatically, if we have a big file, big software which is reading at the same time a lot of records, we automatically need big amount of random access memory, main memory. So if we will look into some existing operating systems, so if we have 32-bit operating system, so we can support up to 4 GB of RAM. If we have 64, so it depends on the operating system, sometimes just up to 2 TB. Sometimes, for example, Unix type operating system support up to 256 TB of data. But what happens if, just imagine I have a file which is about 300 TB. So I even won't be able to open it at once in one computer. So it sounds strange, like, what does it mean to open the same file in multiple nodes in distributed systems? But sometimes it helps. We will be discussing one of the elements like MapReduce principle, which automatically divides the file into smaller elements, processes the file in those nodes, and finally gets the final result, what you wanted, for example, to count something, to search something, as a final result in one node. So one of the ideas when the distributed system could be useful is when you are not able to fit the data into one node. You automatically need to split into some kind of a charts and then process it one after another. But another option is just to use some kind of a distributed system and try to process the data in parallel. And for example, such companies like Google, Facebook, what kind of data, what intensity of data they are dealing. So for example, Google has about 63,000 of unique queries per second. So every second, this amount of queries are coming, and they need to process it and search for the keywords, some kind of information which was requested in about 130 trillion of indexed pages. So some kind of a database. So automatically, if they would be using one computer, it could be very complicated to implement, first of all, because we need a huge amount of storage. Also, it would be slow. What happens if one client request is processed? We need to distribute it. So automatically they are using huge infrastructure, multiple nodes, something like this. Similar situation with Facebook. They have about 100 million of queries per second from 40 billion of users. So automatically they are not able to fit it into one location. And as I mentioned, it's also related to the factor where you are using the system to make sure the latency is smaller, to use the closer one to the geographical location, something like this. So the main area where we are using distributed systems is big data, but not necessary. It depends. Another thing, when we are talking about the cost of distributed system, so for example, if we have n servers, so just assuming this example, it's 2 servers, and we are doing the same task, and we have the same, like if we would be executing it in parallel, does it mean parallel execution in distributed systems will be as fast as like if I have, okay, in this case, n servers, and 5 times I will be doing the same, and our case is 5. So will it be 5 times faster? answer is usually no, because we need some time to distribute the data, to transfer the data from one node to another. So in theory, if we have a machine which is able to process the queries in parallel in one machine, like in a distributed system, it probably will be faster rather than using distributed system, because just as I mentioned, some additional elements are added. But sometimes we have some limitations, and it depends like what solution will be better for you. Another case is when we have also, let's say, n servers, and when we are doing the same task, is the availability higher. So I just tried to illustrate, like if we have some options, like we are duplicating the server. So if this one is not active, I will be sending the request to this one. Sometimes like how to define to which server I will be sending. So it's not drawn here, but there is also some kind of a different solutions for infrastructure, how to balance the queries, how to define, is this node active, to which node I should be sending. So also it's more details which are relevant if you will be trying to adapt it in practice. So if you have a situation like this, we are duplicating the same service. So yeah, the availability increases. So for example, if we have two nodes, so and the availability of one node failure is 5%, so 95% of times the node will be active. So automatically, it's not accurate, but like this area, like 95 multiplied by 95 would be the probability both servers will be live at the same time. Those lighter green means at least one will be active at the time. Meanwhile, the red one, like it will be 5% multiplied by 5%, means the probability both of them will be dead. So automatically, like how to calculate what's the availability of this infrastructure, distributed system, we are just multiplying the availability probability both the server will be not active, so 5% multiplied by 5%, and subtracting it from 1. So in this case, instead of 95, we are getting 99.75%. But if we will have not a duplication of the services, but we will create some kind of infrastructure like phases. I'm calculating something in one node, then this node sends the data in another node. So yeah, we could have some kind of a pipeline which could be effective in time perspective, but this even decreases the availability, because what happens if at least one of those nodes will fail? So basically those two areas are also critical. It means all the pipeline will be gone. So automatically, like how we're calculating, so calculating 95 multiplied by 95, and we get just 90.25%, the infrastructure will be available. So every time when you are constructing the infrastructure, you should be defining what should be the data exchange, which nodes will be duplicating, which will be just sharing the data. And based on it, you can estimate like, is the availability increased based on just one having in comparison to having one node, or did it decreased? And one of the examples, because I was talking about like what happens if I have a huge file and I cannot fit it into one node. So nowadays there are multiple options, like multiple technologies which can be used, big tables and something like this. But probably the basic one, like which appeared and was associated with big data, was the MapReduce principle. So what's happening with the MapReduce principle? Usually we have distributed file system, so there are some kind of files. We already like split it into some blocks. But when we execute the task, like from the client to the final result, what we do, we divide the file into smaller elements. So as I mentioned, like opening one huge file means dividing it and opening separately in different nodes. So when we divide it into some constant size blocks, we are sending it to different nodes. So it was M1, M2, M3. So in this case, task tracker. And what happens in each of those, because basically it's like explanation of those two cases here. We get the input, we do the map function. Map function usually divides the record into, sometimes filters the data, ignores something what's not necessary, and represents it in a key value format. So basically, if we are trying to calculate, okay, the most common example is to calculate how many times each word was presented in the text. So our key will be the word. and the value will be how many times I met it. So usually in this case, we will be writing just one. And instead of writing it to the main memory, usually we are storing it in some kind of an intermediate file. So big data with the MapReduce, like what we are doing, we will be using even more space, but we will be using it in the long-term memory, not in the main memory. So it means I will be reading just, for example, one line by line. So it means I'm reading one line, writing, processing it and writing it in the file. So I'm storing just one line and I'm going to another one. So I don't need to remember what was the previous value, how to sum up something like this. So instead of storing in main memory, I'm storing in the file. What happens next? We do partitioning, combining. So also there is a more detailed infrastructure, but the main idea, like later we will distribute those smaller files into also dedicated servers, the reduce part. And in the reduce part, we just will some kind of aggregate the data. So automatically, what it shows, like we are just using a different technology. More or less the principle stays the same, just the idea how we are processing this data is a little bit different. And why it works, maybe it will help by analyzing this example. So it's not a big data, it's just several sentences. So, but just for imagination what's happening. So we have the file. We divide it into, in this case, two parts. So two nodes could be processing it in parallel. So what's happening next? The map function just does, as I mentioned, the key value pairs. So instead of having this file of 4 words, we will be having 4 lines and some additional value. So if we are talking about the data, what is the size of the data? So in this case, we, as you see, will be increasing the size of the data just because we are adding something. So in this case, like we had like this was once, so I'm not even calculating. I'm just like, I found it. So, okay, this word and adding 1 is this word 1 and this word 1. So just adding 1, 1, 1, 1, 1, and it doesn't matter. So, okay, in this case, I don't have another word, but if there would be, this is an apple, it is useful. So it would be is, not 1, but 2 instances of is in different places. So the next element, which was hidden in the previous image, is we are shuffling it, basically just grouping into some kind of other files for different nodes. So it automatically, based on the words, shuffles it and some kind of groups those similar words into the same chord. So the next step is just the reduce part, which automatically from all the instances, for example, here we had is 1, just aggregates the data and says like, okay, I will be reading until the key will be the same. So until it will be is, and will aggregate the value and I'm getting 2. So automatically, like we did similar steps, we were trusting on the solution. It's not shown here, but with the shuffling, we also ordering the data inside of it if it would contain more than 1 key. So it looks like we even added some complexity. We are storing more data, but the main principle, and probably it will be even slower if we would be writing the code. But everything what we are doing here is related to the fact, like if we will have a huge file with 500 terabytes of data, we won't be able to use the traditional data processing tools. We will need some dedicated infrastructure for it. So distributed systems is one of the options how we can divide the task into smaller one, how to solve it and get the final result, even if it was done in completely different nodes, not related to any memory or timing. And this slide is more about, okay, we have the distributed system, so it means our data is distributed in different nodes. So can I use the data for artificial intelligence model building, how it could be implemented? So also different solutions exist, and one of those is called federated learning. So the main idea behind the federated learning, like if we are having the same situation with big data. So if you know artificial intelligence requires even computational power. So if all of those nodes, for example, in our case 4, will be sending data to the cloud, some kind of infrastructure, and this, just assume one node will be trying to build the model, probably it will be difficult, complicated. And also another aspect is not necessarily we want to share the data. Just imagine if this data is medical data, private data, so I will be sending the data somewhere. I'm not sure how they will be processing the data. So the solution, one of the solutions is we are training the model inside of each of those nodes. So they have some kind of a node, but just based on their own data. And they are sharing the pre-trained models with those in the cloud and some kind of infrastructure. And in this node, we are just aggregating all of them. And we have some kind of adding additional value. So for example, if I don't know, if it was, as we were mentioning, medical data, and if this client is not sick, and this one has diabetes, this one has another diagnosis. So if I will be training just with normal data, it will be difficult to understand, like to classify the data. Do I have diabetes or not? Because I just don't have records like this. And this person is not sharing the records with me. So I'm just building the model. He's building the model. We are sharing it. And based on the shared model, we are just building a common model, which could be shared with all of those nodes. And we could have the combined model and more accurate in this case because it has more data, but we cannot access the data directly. So it's one of the options which could be used. Another option, which is not fully implemented yet in practice for very wide usage, is homomorphic encryption. It's also related to the data privacy. So also, if we have a hospital, we have some data, and we want to build some kind of a model of, if we want to even search for some data, what we can do, we can encrypt the data with the public key. We will be sending the encrypted data, for example, in the cloud. In the cloud, those homomorphic, like automatically adapted algorithms, methods, will be able to process the data. It sounds strange because usually when we are encrypting data, we cannot read it. We don't understand it's just some kind of symbols. So the main idea of those homomorphic encryptions codes are like, we are able to encrypt, no one will be able to decrypt, but they will be able to proceed some basic operations like arithmetic, search of some kind of elements. So it's tricky. So this is why we are not explaining what's happening inside of it. But the main idea, like we are encrypting, we are sharing it. We can do some kind of operations with the encrypted data, not all of them, but some of those. So for example, here we were doing some kind of search of the results, and automatically we are sending the encrypted data. But if I have the private key, I can decrypt the data and see what was inside of it. So it's also one of the solutions when you can encrypt and share the encrypted data. No one knows what's inside of it. But for example, theoretically, we can train the model. We are not sure what's inside, but yeah, we are training. Later, we can provide the same data, gets the result, and if it's needed, to decrypt. But as I mentioned, this is just developed area. So we are trying to extend the availability of those homomorphic encryptions, and it's computing costly. So it's one of the options, but just not very widely used. Yeah, and as a conclusion, talking about the distributed systems have its own application area, like as I mentioned, especially in big data cases, but automatically it has some disadvantages as well. So as you saw in the presentation, I wasn't saying like, yeah, it's always useful to have a distributed system. No, in this case, it's not useful. It depends on the situation. Every time you should be analyzing what I have, what I can spend for the hardware, what kind of computations I can use. So this is why every time, if you want to be an expert in data calculations in distributed systems, you should be analyzing all the technologies, understanding when it works, when it doesn't work, and only then you will be able to understand which technology in which case should be used.